Our job today is to learn how to look at and analyze a quadratic function. I want you guys to know quadratic functions actually do have a lot of really good real-world applications. If you look at the curves we've been graphing and you just think for a moment, you've seen these curves lots of places in your life. Have you ever walked to a water fountain and pushed the little button and sipped water? Not filled your water bottle, but sipped it? This is the path the water takes. Exactly. It's always a parabola. Have you ever lobbed a ball in the air at a friend or into a pond and watched it go pew, boom? It's a parabola. Always. Not kind of like a parabola, not sort of a parabola, it's 100% a parabola. If you played a video game and you've seen somebody jump, and that jump looks like a natural jump, guaranteed in the coding of that game they're using parabolas. Because parabolas do mark, like they do describe mathematically how things fly through the air when gravity is constant, which is pretty much all over the universe. So we're going to talk about like what's the extreme value of a parabola. What's the extreme value? And this is where I want you guys to look at these curves, whether they open up or down. If the parabola opens up like a jump, if it opens down like a jump, or opens up like this, both of these guys have an extreme value. One of them has a maximum, and one of them has a minimum. And if we just think about what those words typically mean, we can probably guess this guy would have a highest value, or a maximum, and this guy would have a lowest value, or a minimum. And it doesn't matter how wide I draw them, or how skinny I draw them. If they open down, they're going to have a max. If they open up, they're going to have a min. No matter what. Now the thing that can get a little confusing for students is when we're doing the math thing, it doesn't take, you guys could probably, if I were to say to you, hey, on this, let me erase some of this stuff. Let's get this guy out of here and leave the middle parabola alone. If I were to ask you where's the highest point on this graph, on this curve, you would all, of course, naturally gravitate towards this highest point. Oh, there's a math word for that. Do you know what the math word is for that? Of course you do. You've been paying attention. That's the vertex. But if I want the maximum value of the function, I don't want the vertex. I don't want two different points. I don't want to know like the x and y coordinate. If I were to say, how high did this person jump, you would measure from here to the ground. You would just give me that vertical component. So that extreme value on this parabola would be the y value of the vertex. So we're going to go through everything I just said and fill in these blanks. And I'm going to read it out to you guys. So basically, the graph of the... let me just pop these words in here that I already grabbed and then read this to you. Give you a chance. You can pause too after I get all these words over here. Oh, I missed something. Hold on. Let me pause my video. Almost forgot a word. So now all the words are filled in. I'm going to read this to you as you copy these things down. Hopefully everything I'm saying resonates with everything we were just talking about a minute ago. If we're looking at the graph of a parabola, the extreme value of that graph, the highest or lowest value of that graph is a y value of the vertex. So if I'm asking for the extreme value, all I want you to tell me is what is the y value of the vertex. It's going to be a minimum if the parabola opens up. Because when the parabola opens up, we have that vertex way down here. It's the lowest point on the graph. The value is going to be a maximum if the parabola opens down, because again, that vertex will be the highest point. So we're kind of hopefully blending common sense. If I asked you, does this have a maximum or a minimum? You would know it has a maximum. That's the common sense part. The math part is now for you to know that value is the y value of the vertex. The maximum value of this is the y value of the vertex. If I gave you a graph that opened like this and said, hey, does this have a max or a min? You would know, okay, obviously it has a minimum. But the mathy part is for you to know, again, same thing, y value of the vertex. So if I'm giving you a picture and I'm like, hey, please tell me the extreme value of this function. And tell me if that extreme value is a max or a minimum. Don't let all these math words confuse you. You're better than that. You're smarter than that. What does extreme value means? Does it have a highest or lowest point? This is what you have. This is my job. My job is to teach you how to read this and convert it into the way you already think, right? So when you see extreme value, you're like, oh, does it have a highest or lowest point? Sure does. Right there, my friend. So, but then you have to know, I just want the y value. I just want that vertical component. So the y value of that point is 1. This function has a highest value. It has an extreme value. That's 1. And I hate to repeat myself, but you're learning this for the first time. I'm picking 1y. Why am I saying it's 1? Because that is the y value of the vertex. I'm looking at this point. I'm looking at its y value. Its y value is 1. And I can just look at this and know that that extreme value is a maximum. These other two things are concepts that are from your Algebra 1 days. X-intercept is where the graph crosses the x-axis, right? It's where it touches the x-axis, where it intercepts the x-axis. So I'm going to look at this graph and see, like, right here and right there, it touches the x-axis. So I'm going to give those two x values. Those x values are -4 and -2. And then the y-intercept, which I'll do in beautiful yellow, is where it crosses the y-axis. So this is my y-axis. This is the graph. This is where the graph touches the y-axis. That's -8. So that's a really brief analysis of a quadratic function. I know where it crosses the x-axis. I know where it crosses the y-axis. And I can say that this one has a maximum value of 1. And again, I got that when we're looking at the y value of the vertex. So let's do a few more examples together and see how this goes.